In today's tutorial we will take a look upon the so-called Wohl-Ziegler bromination. It is a highly selective allylic bromination. What does this mean? For instance, we can start from cyclohexene and we wish to achieve that a hydrogen in allylic position, for instance here or there, is substituted by a bromine. That means this is the target molecule, an allylic bromide. Now to the problem. If we just take elemental bromine together with cyclohexene, then a polar reaction will take place, the addition reaction of bromine to the cyclohexene, giving 1,2-dibromo cyclohexane as the trans isomer, racemic of course. And here we have a reactive intermediate, a so-called bromonium cation, of course with a bromide counter anion. Well, there is a trick to avoid this reaction. If we have the bromine, the elemental bromine, only present in very small amounts, well, catalytic amounts, and also in catalytic amounts radicals, either the bromo radical or the allylic radical, then a radical chain process can take place. This allylic radical can react with the bromine, and in a very fast process the product, the target molecule, is produced and bromine radicals. Those bromine radicals can react with the starting material, cyclohexene, forming hydrogen bromide, and again this allylic radical, which again might react with the bromine. So, where do we get the bromine from in catalytic amounts? Well, we have catalytic amounts of this bromine radical, also very small amounts of the allylic radical, very small amounts of the hydrogen bromide, but the hydrogen bromide will very fast react with N-bromo succinimide, which we have also as a starting component, HBr plus. This molecule gives the succinimide and bromine, which again will react in a very fast reaction with this radical. In the next tutorial we will have a closer look to the mechanism of this process, how the HBr together with N-bromo succinimide produces the bromine. Thanks for listening.